Welcome to the Start Space Be at Sub0, the Polkadot Developer Conference 2023. Let me introduce myself. I'm Albert, head ambassador of Polkadot in Spain. And well, we are going to kick things off with a workshop by German and from Parity Technologies and Piotr from Aleph 0. Please welcome them to the stage. The title of the talk, In Championship.
All right. Thank you, guys. Thank you for joining. So this workshop is not going to be very theory-based, theory-heavy. It's supposed to be a very fun workshop to get you going with your first smart contracts in Ink. And we are going to play a little game. And in the end, so we're going to run a final game where you'll have a chance to earn one of those three cute and cozy NFTs. But more details about that later. So it's very hands-on workshop. So if you have your laptop, please take it out. Yeah, like it's supposed to be very interactive. And go to this link. There you can find Telegram group where, in case you have any trouble, you can just drop me a message, or you can go to GitHub repository. So I encourage you to, clone it, and just go. And we're going to go through the code together. So, has anyone got the link? Can everyone see it? Come on, it's a fun one. It's a fun one. All right, just give me a thumbs up if you're happy with the link. It's Linktree, @ @ink_championship. All right. Yeah, just let me know in case you need, in case you need to see the link again. And for now, I'm going to show you what the game looks like. So this is the game we're going to play. And the idea here is that we have a grid, and your task is to write a player contract with certain strategy to color as many blocks as possible while using the least gas as possible, and you're going to compete against each other. And the first three players are going to win the NFTs, which are going to be minted on Asset Hub later. So for now, I'll go through the game contract and the player contract, kind of just giving an overview of what Ink looks like in case you haven't seen. Also, quick question to the audience: how many of you are familiar with Ink? Just raise your hand if you've heard of it, played with it. Yep, okay. So, how many of you use Solidity? Okay, one. And, okay, show. Yeah. I'm just gonna zoom it in. So here we have a game contract, and what it does is basically the game that we have here. And the game contract uses cross-contract call to call a player contract, and in the player contract, it has one message, one function, your turn, and your task is basically modify this function to return a coordinates like x and y on the grid that you want to color. So yeah, and this is basically all you need to do for this workshop. And think about the strategy you are using, think about the gas usage, think about the blocks that are colored by other players. Because if you try to color the block that's already colored, then your contract will fail and you're just going to waste the gas. So what this strategy does is basically with every turn it colors the block on the diagonal. And I'm going to show you a little demo how it basically works in practice. So we have our contracts UI, and I already deployed a simple player contract than the one you saw previously. And I just copy the address of the contract. I go to the demo contract of the game, and I want to register a player. So I choose the simple player, and the buy-in for the game is one a rock on a testnet, one token on a testnet. I register the player, and we should shortly see in the list of players. The finality on rock on the testnet is 6 seconds, so it takes a while. So in case you have any questions about the setup at the workshop, just let me know. Okay, and we are in. So now, if Piotr would be so kind to run the script, we will see the player with every block, with every round, coloring the grid on the diagonal. Yeah, I need to start the game. So now I start the game. Okay, so takes a while. Okay, so in the meantime, while we're waiting for the transaction to get into a block, I want to talk about Ink. So in case you're not familiar with Ink, Ink is an embedded domain-specific language. It's based on Rust. And the reason why it's embedded is because it uses pure Rust. It's basically a Rust library with a bunch of macros that allows you to turn your Rust program into wasn't compiled executable that then can be run and interpreted by palette contracts. And palette contracts is a module, a part of Substrate that essentially executes Wasm smart contracts. And as a part of compatible languages, we support Ink, which is our first-class domain-specific language. We have Solang, which is a Solidity compiler that compiles to Wasm, and we have Ask, which is a JavaScript-based smart contract language. And as of now, you can use Ink on A-star mainnet, Fala as off-chain contracts, and Interlay, and also Aleph 0. And also we have a very welcome guest. Oh yeah, we can see the blocks coloring. So what happens every turn? The game contract calls a player contract and asks for a coordinates. And once the coordinates return, it tries to color the block on behalf of the player. So we have 5 rounds. So like with 6 seconds, that roughly takes 30 seconds plus or minus. And while we're doing that, I just want to give an overview of what the smart contract looks like. So, like as a Solidity, we have our storage, and it's defined with a storage macro. Then you can have different fields of different types. We support mapping. We have also mapping, and different data structures supported. Then you have your constructor. In comparison with Solidity, Ink can have multiple constructors. And when you instantiate the contract, you can choose the constructor to use. And then, like in Solidity, you have messages. And also the feature we have in Ink is that you can specify a custom selector that allows you to essentially rename your function, rename your code in future, and kind of provide this explicit visibility to the user. So, how are we doing with time? Now, I think I will pass to Piotr to talk about tasting strategies. In case you have any questions about the game, the workshop, or the strategy of how to write it, just please let me know. Or in case the instructions are clear, just raise your hand. I'll come over to you and help you. All right, Piotr, I'll pass it over to you.
One second. Looking for my cursor. Okay. Keep changes.
Like, how is it supposed to interact with the already deployed contracts? Like, where do I find the
All you need to do is just write the strategy inside the message. Do not modify any other contracts. Just write the strategy how you want to color the blocks. And when you instantiate the contract, you need to specify the dimensions of the grid, but it's 10 by 10. So you assume the grid is 10 by 10. So you need to write a strategy depending, on the grid size. Right. Sure. Yeah.
Sorry, Ubuntu. Okay, so assuming that we have already written our player contract, it's usually a good idea to test it. Before things get serious, we send it, we register it in a game and pay some money. It's a reasonable thing to, well, verify its logic, whether it behaves as expected, and as well maybe simulate it and see how it behaves against opponent strategies. But there are a lot of possible approaches how to test a contract, so starting from a very simple lint checks that will check for common vulnerability patterns, and ending with fuzzing procedures will actually focus on three main testing strategies. But before we understand what they are about and what are the differences, we'll make a quick dive into the architectural design of how smart contracts are executed in Sub0. So we'll make a short case study, assuming that investigating what happens when we try to call a contract. Okay, so let's assume that we want to call any contract. So we have to express our intention by sending a transaction to a validator node. Okay, so a validator node essentially runs a binary, runs some process which we call host. It has a lot of responsibilities like networking, block production, finalization, state management, all that stuff. Once the validator gets the transaction, the contract call, it has to process it, right? So what I mean by processing is that we'll have to actually update the state, right? So in order to compute the new state, what happens after executing a contract call, we'll have to spawn yet another process called, in Sub0 word, runtime. So runtime is essentially a state transition function which gets as an input the old state, the transaction, and computes a new state, right? So just to recap, transaction goes into a node, and node spawns yet another process just for the state transition function computing. However, if our transaction is a contract call or any contract interaction, we'll have to spawn, well, yet another context, yet another environment just for executing this Inc smart contract. It's pretty similar to what happens on Ethereum or any blockchain. We've got this onion, the execution onion, right? It's pretty complex, but well, we can dive it in. What we have is a stack, a technology stack. Our contract is executed actually here, but with the context of both state transition function and a node. And by taking three different, by looking at three different parts or segments of this stack, we can come up with three very different approaches to testing. So depending on the part of the stack, the technologies that we are focusing on, we can take advantage of their, well, strong sides, or weak sides, and well, we'll suffer from their problems. Okay, we'll start from the easiest one, from unit testing. Okay, so if you go to this repository that German shared with you, then in testing strategies there are all the sources that we need. So I have written my player contract. It's a very simple strategy, and I can show you the contract, how it looks like. So my turn is just, we've got some counter, and we'll just take the consecutive field, the next one that we have, the adjacent to the previously painted. Okay, and in order to test it, using unit test approach, well, what can we do? Let's go back here. So we are limited only to this uppermost layer. So we do not have any context, any state transition function, any storage, any node, nothing. Therefore, there is not that much that we can do. What we can think about, how we can think about unit testing is like in classical engineering, it's a component test. A contract is just some module with public API, and what we can do in unit test is just a pure Rust testing of this part, of this software part, right? So what can we do here is we can check whether the instantiation, the constructing phase is successful, and also we can try calling this this myturn method with different settings, with different board sizes, with different initial counter, and assert that the coordinates that our player returns are as expected. Okay, this is usually the first test that you will write. It's very easy to write to implement, and usually it will catch all the easiest errors. On the other side of spectrum of testing strategies is testing the whole stack, meaning end-to-end testing, right? And this is what you really want to do if you are deploying a very serious application. So if you are deploying some swap smart contract which will hold a lot of dollars, you really want to test it as it was in a production. So what will happen in end-to-end tests will interact with our contract by sending a transaction to node. Then the node will spawn this state transition function, which will spawn this contract execution environment, and the whole stack will be transitioned up and down in order to process our interaction. Okay, so in end-to-end tests, we can do a lot more. So of course we can check instantiation. However, please notice that it requires a bit more code, especially because what happens is that for every test case, a new separate independent blockchain is spawned in the background. And actually what we are doing here, we are sending over local network transactions to it. So in order to instantiate a contract, we'll just send to another process or intention, and things get asynchronous, and so on and so on. Apart from instantiation and checking the strategy, which we also could have done before with unit tests, we can do much more exciting stuff, simulating the whole game. So worth mentioning, Ink as a language, it comes with a built-in native end-to-end framework, test framework, which actually allows us to pretty simply, pretty easy set up everything that we need for running such scenarios. So here I declared that I will need one contract more in game, the game contract, and I will instantiate both contracts. I will register my player, we'll register it here. And then I will just simulate the game. And afterwards, if everything went fine, I should be able to end game without any error, right? But we can go even further. We can simulate a game with multiple different players. So you can see that apart from my player here, I've got also a corner player and a round player. These are pretty dummy players, but they are different. So here in the last test case, I can deploy all three players, register them, run the game, and in the end, I can check that actually the game is finished, that there is somebody chosen. I cannot assert who it is because this round player can make things unpredictable. Okay, but what are the downsides? What are the downsides of end-to-end test? well, it has some overhead for this communication, for spinning a blockchain in the background. And well, usually you will use here your target node. So if you are deploying to Moonbeam or Aleph 0, you will use the dedicated node. And if this node has a block time of 6 seconds, for example, then if you want to simulate your the economy of your contract for like 1 month, you will have to wait 1 month. It's not it's straightforward, right? You have to wait for block time, for block finalization, and so on. And things get it's real testing, but it might be pretty onerous to wait, right? For example, if we would run this test simulation on a Rococo node, then well, this test case would run for, depending on the rounds, like for example, for a minute or two. That might be pretty cumbersome or onerous during local development, right? Also, you might fail into some problems with setting up a node in the background if it's a very special node. Asynchronous API also might be sometimes not very handy. So there is a third option, testing strategy. It is pretty fresh. I built a library. I mean, it was born like 3 months ago, but it's already pretty useful. There are already some projects who use it in their testing pipeline, and it is an approach that I like personally to call it quasi end-to-end testing. So the idea is that we completely forget about node layer. What we are using is just the state transition function with the state and contract execution environment. So the difference is that we keep all the storage, our blockchain, in memory. There is no actual node running in background. We have a direct access to the state, to the contract execution environment, and therefore things get some things are much simpler. Okay, so this is the trade-off. We make a step further from a real testing, from the real environment. We don't submit a transaction, we don't run a node, but instead we get a much simpler, much easier interface for interacting with our contracts, with the blockchain itself. So the library that I built for it is called the Drink. That's why this module is called the Drink tests. And with Drink tests, you can do pretty much the same as with end-to-end testing, right? So there will be this instantiation, verification, strategy. So the things that we could have done with unit tests, but of course also the simulation, right? So we can build contracts, all our 3 players, deploy them to our in-memory blockchain, right? And then run the simulation just as we did before. Okay. The big advantage is that it's instant. There is no block time. So, for example, if we were to simulate this game for like 30 rounds or even more, it's pretty instant. We don't have to wait. But please notice it's a pretty important thing to keep in mind. That Drink is useful. This quasi end-to-end is especially nice for local development, but this is not something that to substitute end-to-end tests. So if you are about to deploy a serious application, you really want to have end-to-end testing. So just to ensure that all components play smoothly with each other. So fortunately, for the last 2 months, together with Ink team, we integrated 2 things: Ink native end-to-end framework and the Drink library. So as a result, we can have a single function, a single test code, which uses the common API, common interfaces, and we can just choose with with macro argument which backend should be used. So, for example, for local development purposes, we can just use randomly this drink backend, which will be instant, very smooth, fast, and with no network setup and so on. But in our CI, in our nightly pipelines, or before release, we can just use the classical backend, which will run a node and perform the whole verification in the real environment. I think that's everything about testing strategies. I can hand over the presentation to German.
All right. Thank you, Piotr. So for this part of agenda, we had Sam talking about front-end and use Inc. Front-end library that he single-handedly wrote. But unfortunately, he couldn't make it today. So I'll try to basically kind of summarize what it's all about. And just for records, I'm not a front-end developer. Last time I used React, I was building a website for Minecraft server. So that was about my front-end experience. But so the background story behind Use Inc. library is it's heavily inspired by Use DApp, which is one of the popular libraries in EVM world, and the library itself originated from the game front-end. So if you look at the game front-end, you can actually see all the components and hooks, and that's where the Use Inc. library emerged. And actually, some of you might have navigated to Smart Faucet, and I originally created it in case the faucet is drained and we want to airdrop some of the tokens to you so you can play the game. And as a part of the Smart Faucet, we have a front end. And front end actually uses Use Inc. library. So the main file we're going to focus right now is app.tsx. And if we have a look, the way it works that we have lots of components coming from the Use Inc. library, and it's based around hooks. So we have a use wallet hook that's basically, it has integration with main popular Polkadot wallets like Sub0, Talisman, Polkadot.js, etc. Then we have a use contract where we provide the contract Rococo address with metadata, and that gives us interface that allows you to interact and send transactions to the blockchain like butter smooth. Then we have a separate transaction hook that allows us to build a transaction, which can be later sent, and use call subscription essentially sends the transaction with every block and updates the state. So I'm just going to show you a little demo how it looks in practice. So this is the faucet, and like Sam likes to put the audio in on all his front end, and we can see that we have withdraw 10 rock, and actually this value is updated through the call subscription hook, because the contract itself allows you to modify the value that's going to be airdropped to you, and this value can be modified by the admin. Here we decode the value, and we convert it to Planck or to decimal, and we use memo from React, and later we have like our typical React program where we have where we can just plug the values into the functions and then build our static HTML. And then the interesting bit is here on click hook, we just call, sign, and send, and which basically automatically connects with wallet and tries to get the confirmation. So if I try to withdraw 10 rock, yes, now I can approve the transaction and receive 10. So now we have a notification here on the bottom right corner, waiting for Rococo to finalize the transaction. All right. and we are in block. And you can see that the balance has been updated in case you don't see it. Here we go. So again, I would love to talk more about front end, but unfortunately my knowledge on React and JavaScript is very limited. So I hope it gives you a nice overview. You can learn more about useinc by going to useinc.com. It's our general documentation where we have a documentation both for Inc smart contract language, and you can also find the tab for front-end development where you can have well-detailed documentation for useinc front-end library. And this is essentially what I used to quickly bootstrap this application. So just to give you like overview, like I myself not a front-end developer as I mentioned before, but it didn't take me too much time to actually figure out with kind of examples how to build my own front end. And if you want to see like more examples for the front ends, then you can navigate to Inc examples, and you can have lots of examples with ERC contracts, with PSP contracts, and I think some of them have front ends. So that's that. And now we have 19 minutes for the game. So question for the audience, for the ones who are coding the contract, have you managed to code your strategy? Because the way we're going to go now is we're going to have one test round for you to kind of get the feel how the things work. And then we're going to have a kind of official competition. So, are you guys ready? Are you ready with your game contract? You already deployed. There you go. What about others? No? You need any help? So, if you want to get testnet tokens, you need to go to useinc.com, and then I think there's a faucet somewhere. Yeah. No, you only deploy your player contract. Do not. Okay. Okay, so after you deployed your contract, yes, you need to compile a game, but you only need the metadata, because when you go to contracts UI, you click add new contract, use on-chain contract address, and I'm going to drop the contract address to the Telegram group. Yep. You add the contract address. So the one that we need, I think Piotr going to send it, is Piotr going to send the contract address, and you grab the metadata from the compile contract, and you add it on contracts UI. And once you've done that, so this is the contract that we're going to play. You register the player, and you choose your contract you want to register. You put your name, whatever you want, and hopefully we are gonna see you on the board. So I'm gonna just grab this contract address. I'm gonna go to Ink Splash. I'm gonna return to the main menu. Put it in the text field. Okay, so the game is ready. Now we're waiting for players. Once you join, you're gonna see yourself on the board. So just to recap, so what you need to do, you need to simple player. So use simple player as a template. You only need to modify this function. It returns two coordinates options. So sometimes you can choose not to return anything. So you can like skip return if you choose so. But essentially, yes. You only need to modify the body of this function. Do not touch anything else, otherwise you're going to break things. So, yes, you're given dimensions. Just remind the dimensions, it's a 10 by 10 grid. Also, you need to think about different players on the grid, because if you try to color the block that's already colored, the transaction is going to fail and you're just going to waste gas. So keep that in mind. for the advanced levels, originally we planned this workshop to be a little bit longer. So you start with the simple strategy, and then we're going to dive into cross-contract calls, because what you can also do is just kind of a side note for future. You can also call the game contract from your contract, kind of re-enter the game contract, and request the state of the given cell on the grid. So like to kind of test whether the cell is colored or not, and choose to color it depending on the state. But yes, we only have 50 minutes left. So yeah, you can just slightly quickly modify your strategy, don't worry about it, and just join the game. We're gonna run it, it's only 10 rounds, so like 1 minute. Takes a while. So how are we doing? So while we're waiting for people to code their contracts, are there any questions about ink, testing strategies, or front-end library? No? Sure. All right. In the meantime, just also wanted to mention that in the end, but while we're waiting for people to code their contracts, there's also going to be an Ink Focus Hackathon by Encode Club taking place in October. It's online, and I think Aleph 0 are going to have a bunch of workshops, very useful workshops, and I'm also going to do a workshop, but it's basically going to be just kind of a copy of that with a slightly modified version with a little bit more advanced strategies. Yes, it's happening online. Exciting opportunity for you to try out your coding skills. It's fun. Just get the people together. Also, if you have any questions for me, again on Linktree there is a Telegram group dedicated for this workshop, so we can just also exchange addresses in case you need some testnet tokens. But also, if you have any questions about Ink, feel free to drop me a message on Telegram or in the group chat. All right.
This will be.
It's the game. Okay, so it's a test one, dry run. Yes. It's a dry run. Oh yeah, just Piotr is gonna send it in a sec. Yeah. Yeah, he sent it. Yeah. All right. Okay, let's see. So who's going to join the game? Okay, just raise your hand if you're planning to join the game. So we kind of have an estimate of people, you know. So I know Danius is going to join. All right. Come on, we have 10 minutes. All right. On. Oh yeah. Sorry, I just forgot to mention. Yes, in case you try to deploy a contract on chain, the buy-in is one test token. Yes. So that means that when you register your player, the value you want to provide with the call is 1. Because the buy-in is 1, it's like a game, so the winner gets the pot. So everyone just, it's like poker, you know. Okay, we can see Daniels on the board. All right. We're gonna have more people joining the game. You want to deploy one? Yeah. That's fine. We're gonna start. We're gonna start in 1 minute. Just all right, so I'm gonna start the game. Yeah. Oh, and we have Piotr now. Just in time. Okay, so the game is ready. Now we have 10 blocks. Should give us roughly enough time to finish on time. Okay, interesting enough. Huh?
Coco is hang. Oh.
Is That would be interesting. Oh well. Dennis, what was your strategy? Yeah. Yeah, I know. Like it's just not coloring. I don't know why. No, I don't know why. It can be only for only one reason. Is because all of you trying to color the same block and none of you are getting the one. I mean, if you're starting to color the same block, then none of you are going to color the same block, and then it's basically just, yeah. All right. Yeah, unfortunately, we're over time, so I'll just encourage you to learn more about ink, participate in ink workshop, and again, big thanks to Piotr for bringing this massive contribution with quality testing. A big thanks to Sam for writing this amazing library, again, which can essentially enable so many great applications with use ink. And thank you for joining us for the workshop. I hope you learned something, and I'll see you later. Thank you, guys.
Thank you, German and Peter.